Hello, hello, hello. All right, folks. Well, this is the fourth recording of the same set of notes, and so hopefully it works this time because so far not so good. So today we are going to be working on doing some factoring, and then with the zero product property here, if the product of two factors is zero, at least one of the factors had to be zero. So for example, if you have 5 times 0, that equals 0. One of those two numbers had to be 0, or you don't get the solution of 0. If you have 6x equals 0, x has to equal 0. One of the numbers has to be 0 when you multiply, otherwise you never receive that answer that you want there. So when we go through these types of problems, first thing we want to do, step number one, is make sure all the terms are on one side of the equation and that you have an equal 0. Then you want to factor. You want to see parentheses, something along the lines that looks like that. You want to see parentheses. That means that hopefully it's factored. Then you want to set each individual factor equal to 0 and solve it. I'll just say we'll tee it up, and break it up from there. And these equations have more than one solution. They may have, anytime you have an x squared, that 2 represents how many solutions there are if you have a problem that has that with an equal sign. So let's go to the first group of problems here and see where we're at. So again, first thing we do when we check these problems is, do we have an equal sign and does it equal 0? Yes, in this case it does. Second thing is, do you see parentheses here? Yes, so that means it's probably factored. So let's tee this up, see what happens. So when we tee it up, we go x plus 2 equals 0, and then x minus 3 equals 0. And then we solve both of these. Subtract 2, so x equals negative 2. In this one here, we're going to add 3, so x equals positive 3. And then when I write these answers out, we put them in the little brace form here. So negative 2 and 3 are your solutions. That's not the same as a parenthesis, negative 2, 3, which represents an ordered pair. This would be wrong. So you want to answer in these little brace form here. And then obviously we can check to see if these are right and plug it in. So let's say I wanted to check this one right here. Check the 3. So 3 plus 2 and 3 minus 3. 3 plus 2 is 5. 3 minus 3 is 0. 5 times 0 is 0. So that one does work. And obviously you can check the other one and get the same result. Let's try number 2 here. Again, with number 2, first thing we do is check, is there an equal sign and a 0? Yes, there is. Is there parentheses? Yes, that means that it's at least somewhat factored, if not all, so it's all the way factored. Let's tee this up. D minus 5 equals 0. 3D plus 4 equals 0. So in this case here, we want to add 5 to both sides, so D equals 5. Over here, we subtract 4. 3D equals negative 4. We want to divide by 3, so D equals negative 4 thirds. Final answer again in brace form, 5 and the negative 4 thirds. Final answer. So next slide here, obviously we're going to get a little bit more challenging in these problems. What you need to take a look at is, again, do we have the equal sign? Do we have an equal 0? Yes. Do we have parentheses here? No, we do not. So again, if you can look at these problems and see what is the greatest common factor, take that out, leave what's left in parentheses. I'm gonna go the long way just on the first one to give you a better idea of what it looks like. So if I were to break down these as a product of primes, 3 times x, the negative 15x is negative 1 times 3 times 5 times x. So again, just like we did the other day, circle what's common between the two. What's common between the two is 3x. What did we not circle for the green? Let's put that in parentheses as x. In blue is a negative 5. And again, you can always check and just redistribute if you want to make sure that we did it right. If we did this, that would be 3x squared. And then if we went here, 3x times that negative 5 is negative 15x. That's just one way to double check, make sure we're solving these right. And again, these still do equal 0. So if we check our problem again, does it equal 0? Does it have parentheses? Yes, it does. So let's tee this up. 3x equals 0. X minus 5 equals 0. So then we want to go ahead and solve these. Divide by 3, we get x is 0. Add the 5, we get x is 5. Final answer here is 0 and 5. All right, let's go back up there to number 4. And number 4, again, the question we ask is, do we have an equal 0? We do not. So what we want to do here is we want to bring one of them to the other side. I can see that this is a y squared and that number is positive, so I'm going to subtract the 4y over because I want to keep the 12, the number in front of the biggest variable, to be positive. So I'm going to have 12y squared minus 4y, and when you subtract these two out, we get a 0. So now we have a 0, so that's a good start. Is this factored? It is not. So again, if you have to go the long way like I did on the previous problem, go ahead. If you can just automatically see what's common between and take them out, take them out. So in this case, that's 4y. 12y squared divided by 4y is going to give you 3y. Negative 4y divided by negative 4, divided by a positive 4, some people may say 0. If you do that, that's going to be wrong and you're going to lose a term. And that will just kind of eliminate itself, which is not what we want. So negative 4y divided by positive 4y is a negative 1. That equals 0. So now we have an equal 0. We have a parenthesis. Now we're at the stage where we tee it up. 4y equals 0. 3y minus 1 equals 0. So from here we're going to divide by 4. Y equals 0. We're going to add the 1. 3y equals 1. I'm going to divide by 3. And I'm going to get this to be y equals 1/3. So final answer here is 0 and 1/3. I'm going to stop here and then finish if this works.